All right, welcome to lesson number 4. We're going to look at analyzing puzzles and games. And so in this first investigation, Chris is a computer program, and he is designing a digital arcade for an iPad. The game will have 10 levels of difficulty, and with the first level being the easiest. So at level 1, the object is to drop the ball so it lands on any of the exits marked by one of the letters. And so A, B, C, D, E, F, or G, and then we have an illustration of what it looks like. So first thing we want to do is determine how many ways there are to get to each black dot, and then we want to write the numbers over each of the dots. And so let's see. Well, first of all, to get to dot number 1, there's only one way to get there, and that's straight down. To get to this next dot, he has to go straight down and over. He can't go over this way, and so there's one way to get here, which means there's also one way to get to this next one, and it's by going down this way. That means there's only one way to get here and one way to get over here. And if you're looking at this, you might be seeing a pattern arising here. Next, to get to this black dot here, well, he can go down this way, which would be one direction here, so that's one way, or he can go down in this direction. So there's actually two ways to get to this dot here. Next, to get to this dot, he can go down he can go this direction, so clink, clink, clink. So that's one way. He can go down this way, clink, 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 that's another way. Or he can go down this way, clink, 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 and that is three different ways he can take to get down to this dot. Well, if we were to continue this pattern, then there would also be 3 ways to get to this triangle. And so explain a pattern that may be developing. Did you use inductive or deductive reasoning to find the pattern? So if we have each number above, we have a black dot that appears here. And if we look at what's going on here, well, for every dot, it appears that it's the sum of the numbers before it. And so here, for this dot, it would be 1 plus 1. If we look at this dot, it would be 1 plus 2 would be 3, or 1 plus 2 is 3. Right now we're kind of making an educated guess based off of this information, and so this looks like, well, this is inductive reasoning. So we are using inductive reasoning since the ball appears to be present as the sum of the two numbers before it. And so right now we kind of just made an educated guess based off of what's going on there. Use your strategy to determine how many ways there are for the ball to reach letters A through G. Okay, well, let's see here. To get letter A, well, if we continue down this path, there's only one way for the ball to actually get down to A. Now, if we were to continue our pattern above here, then this next one here there would be 4 ways to get to this triangle, which means there's 5 ways to get to B here. And so 5 and 1 here would give us 6 different paths to get to B. Again, if we continue this to get in the middle here, there would be 6 different ways and 10 different ways to get to this triangle, but then to get to C, there would be 10 and 5, which would be 15 different ways to get to C. And this side is essentially going to be, well, it is going to be mirrored, so everything here is going to be 1, 1, 1, and then 1 to G, everything here is going to be mirrored over here, so 10, 4, and 1 is 5, The only difference is to get to D, there's 10 and 10 ways to get to these triangles. So to get to D would be 20. And then we would have 15, 5 and 1 is 6 and 1. And so that means to get to A, there's only one way you can get to A, but to get to B, there's 6 ways. To get to C, there's 15 different ways. To get to D, there's 20 ways. E, 15, 5, 6, and G, 1 way. All right, so refer back to lesson 1 of this unit, assignment number 2, page 68. How does your explanation of the pattern you determined compare to that of question number 2? Well, if you look at it, we're working with Pascal's triangle again. And so we could say we're applying Pascal's triangle. All right, so what did we just look at? Well, we just looked at something known as game theory. And game theory was a mathematical model that was determined by John von Neumann. He's also the first one who was able to create a programmable computer. And what game theory is it's a theory used in economics, and it's based off the premise that your decision is an outcome based off of other people's decisions. And so if we look at how game theory is applied in games and puzzles, the choices you make are largely based off of the choices others are making. And so, for example, if you're playing Monopoly, you might not want to buy a hotel because of a choice that somebody else made. And so you want to, instead of buying a hotel, maybe you want to buy another property, for example. Or if you ever play Settlers of Catan, you have to make your decisions based off of others. And in essence, that's what game theory is, and that's what this lesson is going to explore. So I'm going to give you the opportunity just to read this section. And so I think what you should do now is just pause the video and just read what the scenario is, and then we're going to continue. All right, so welcome back. If you paused, if not, then let's continue going on here. So Wen and Harry play the simplest variation of this game called NIM to see if a winning strategy can be discovered. They set up one pile of pennies, and each player must remove 1 or 2 pennies from only from the pile, and then they need to alternate turns, and the player to remove the last penny is the winner. And so number of pennies the NIM game begins with, so it goes from 1 to 6, and then winning player, player 1, player 1, player 2. So Wen will be player number 1 and Henry be player 2. They begin with 1 penny on the pile and start the game over by adding another penny each time until they reach 6 pennies. And so they're going to play the game several times with a partner and see who wins. And so if you play the game with 4 coins, can you come up with a strategy for player 1 to win every time? So what we want to do is complete the table and complete the list of reasons for players winning started below. So reasons for players winning. Starting with 1 penny, player 1 wins because he takes the penny and he wins. Okay. Starting with 2 pennies, player 1 wins because he takes both pennies and wins. Starting with 3, player 2 wins because no matter whether player 1 takes 1 or 2 pennies first, 1 or 2 pennies are left over for player 2 to take. Then starting with 4 pennies, player 1 wins so long as player 1 takes 1 penny and leaves player 2 with 3 pennies to take from. Player 2 must take 1 or 2 pennies from the 3, leaving 1 or 2 pennies left for player 1 to take and win. And so if we start with 5 pennies, and so first of all, player 1 won the round with 4 pennies. If we have 5 pennies, if we want player 1 to win, he has to take 2 pennies, and then he leaves player 2 with 3 pennies to take from. So we'll say P1 takes 2. So P3 is left is left with 3 to take from. So player 2 must take 1 or 2 pennies from the 3, leaving 1 or 2 pennies left over for player 1 to take and win. And so player 1 would win this round. So this was round 4, this is round 5. So with round 6, starting with 6 pennies, player 2 wins no matter how many pennies, because player 1 has to take, player 1 will take because player 2 can then have enough to leave player 1 with 3 pennies. And no matter what, player number 1 has to take 1 or 2 pennies, right? And so if there's 3 to choose from, then player 2 is going to win each time, because player 1 has to either take 1 or 2, and if he takes 1, then that leaves 2 for player 2 to take. Okay, so it is Wynn's turn. What is the smallest number of coins that can be left by Henry so that Henry knows he will win? Well, that was 3. So if it is Wynn's turn, what is the second smallest number of coins that can be left by Henry so that Henry knows he will win? So Henry is player 2, and that was 6. So Wynn and Harry realize that a winning strategy may involve a link between the number of pennies in the pile and the number of pennies the first person removes. So if we play the game several times, a 7 pennies and divide strategy to ensure that player 1 always wins. Player 1 should always take only 1 penny and leave player 2 with 6. And so repeat for 8, 9, 10, 11 pennies and complete the table below. And so you can take 1, 2, 1 or 2, 1, 2, then he has to take 1 or 2, and then the winning player here would be player 2. And then 1 and 2, and then the winning player here would be player 1 and player 1. So if he takes 1 or if he takes 2, then player 1 will win. If 1 or 2 are left, then player 2 is going to win. And then 1 and 2, player 1 wins these matches as well. So which player has control of the outcome of the game if the original number of coins in the pile is 12? Well, based off of this trend here, this is going to be player 2. With 25, so 25 would be player 1. And so if you're looking at this trend here, if it was a multiple of 3, so 12, it was always going to be player 2 with multiples of 3. Player 1 would win because 25 is not a multiple of 3. 50 is also not a multiple of 3, so player 1 is going to win that. 300 will most likely be player 2 because, again, it's a multiple of 3 in our, oh, sorry, I can't say that, in our chart here. And so with this last example, we'll look at this one in class just as a way to kind of revisit game theory and analyzing puzzles in games before you start the lesson.